But at some point you have to try to graph this. And you can't see what I just wrote, so it makes it even tougher to understand what I'm talking about. But I'm going to hit the little freeze button here. The initial condition is negative 1, 0. That's the starting point. So you're going to plot negative 1, 0. And again, I'm still a little bit confused if you're actually on the little line segment, because I don't really think the line segment's there. It's more like a track. So I'm going to go negative 1 as soon as I find that little rot. So I like to do this. I go right above it. See, there's my dot, my negative 1, 0. And the idea here, and I know this is awkward, you stay in the track you're in. Your track says right here you're going up by 1, so you go up by 1. And then it kind of bends this way. And then it flattens out, and then it goes back up this way, and then I don't know what it does. That's the track you were in. That's the graph they'll look for.
Oh, so it's in between the sections?
Yeah, I think of them as train tracks, and you can't ever cross. And what's awkward is, like, this can get hard. Like, you could be going through here, and you're like, well, they turn, especially if they turn really sharp, you're like, which track am I in now? So you always follow this line segment at this angle, and then you see what the other one is. If it's steeper, you have to start getting steeper to go up to it. And you don't cross any of those little line segments that you put on there, because otherwise you're switching to another graph. Yeah.
Is it, how come at the point of negative 1 for x, how come that's not a negative slope?
Negative 1 for x, not a negative slope. Well, let's see. 1
Oh, wait,
plus
no, yeah, sorry, my bad, I haven't figured it out.
negative, negative.
Yeah.
You've literally, you're going to get, I guarantee it, you're going to get a problem on the AP test that has an A, B, C. You really, already, I haven't really taught you much, to be honest. You should be able to do A and B. A is going to be some sort of a question about either plugging into it or finding slope. And if you understand dy, dx means slope, you can do it. The second one is going to be either you're going to make one of these, or they're going to give you one and you're going to have to stay in the tracks. All those, they add up to about 4 of the 9 points. The other 5 points usually come in one section, and this is the big dog. Yep. And it's called separable equations. So the hard part to a differential equation is when they want you to find the original equation. This working with differentials isn't easy, but it's also not crazy high level. You're like, hey, it's slope, I got to draw line segments. Finding the original equation can be pretty tough. All right, so we've looked at first order differential equations. They're called first order because you didn't see any second derivatives, things like that. We've looked at it from a geometric point of view, the slope fields. It'd be nice to have an explicit formula, which means an equation, for a solution to a differential equation. Unfortunately, it's not always possible. Now, the stuff that I typed up here next would be really cool if I was on a document camera, but on a PowerPoint, I don't know if it's going to work. There are lots and lots and lots of types of differential equations. The AP will test you on about 2 or 3 types. So we're just going to look at those types. This is not differential equations, the class. I'm not going to teach them all to you. So a separable equation is a derivative. It's a first order equation, first derivative, that can be factored as a sum of x times y. So this is technically the idea. This is an example of one that's separable. This is one that's not. So we're going to hope and pray they give you this. They put these kind of problems on there for 10 years now in the BC. 1 year, I think they screwed up on one of these on. I don't think they meant to. Okay, so here's what I mean by separable. I'm going to show you some slides here. I think. So the name separable comes from the fact that the expressions on the right side can be separated. These can be separated because it's multiplication eventually. That makes it really hard to separate them. All right, blah, blah, blah. That doesn't make sense, I'll say. Now what we're going to do is cross multiply. All it is, when it calls separating, you can't integrate this side right now. And I could go to Brandon and say, Brandon, why can't we separate it? And he would, or integrate it, and he'd be like, well, we don't have their widths. We can't do that. Remember, you have to have a dx or dy, dt to integrate it. If you want to integrate something in terms of x, you need a dx. If you want to integrate in terms of y, you need a dy. So this one's separable. Now watch how I have to do it. Just give you an overview where we're heading. dy dx has a top dy and a bottom dx. Thank you, Leibniz. He made a little bit easier notation for us, okay? So if you cross multiply, think of it just like a fraction. you get x, y times dx equals 1 times dy. Well, that's the type they usually give you. That's still not integrable. Integratable? Let's try that. Because you have an x, y, dx. You can only integrate x's over here. But because of that multiplication sign between them, you could move the y over. How could I move that y over? Divide both sides by y. And now you have the x with the dx, which means you could integrate that. You have the 1 over y with the dy, and you can actually, and that's very classic for what they'll give you. Now think about y. No. This is dy dx. Just in your head, if you integrate dy dx, what do you get? Does anyone know? This is pronounced the derivative of y with respect to x. If you integrate the derivative of y, what do you get?
Find the y.
You get y. So your ultimate goal is to find what y equals. Well, if you integrate this side, what's the integral of x?
1/2 x squared.
1/2 x squared. What's the integral of 1 over y?
It's natural log.
You better have that down. Guarantee it's on the test right there. That problem.
Natural log of absolute value of y.
And the only thing we have to learn is just like there's a Hodifi, you have to have a c value. We're going to talk about why it only needs to be on one side. Now, eventually, you're going to try to solve it for y, but that's called separable. Remember, your goal is to get to what y really equals. Well, we have a chance now because there's a y in the equation. The only way to get to a y is to integrate it and actually get to that point. You have all these derivatives in here first. What you got?
So suppose dy over dx, then is it like, does it work out for cross multiplication? Just like, dy isn't really like dy divided by dx, right?
You know, that's interesting. I wish I could pause this and go to the whole thing, but it's not. But that's, two different mathematicians came up with these ideas, and one of them was very cognizant of how to do things like that and realized people would struggle. And you're basically, it's not a fraction, it's really not, but it works to that way. If we have more time, you get to see that. So this was me showing it on here, how I was going to be able to integrate both sides, but without a document camera, I can't really do much on this. So, all right, here we go. We're going to, now remember, they aren't going to throw this at you part one. You're going to get some big question, and then it's going to say, hey, here's the weight of the bird. Find how much is it increasing here. Very crazy, just plug it in. Then they're going to give you a slope field, and then they're going to say, they're actually not going to say solve the differential equation. They're going to say find the particular solution with the initial condition. But I'm going to go ahead, man, is that the first problem I planned? All right, we'll do it. I'm going to try to solve this, hopefully in this space. I don't know if I can. First off, where's my red dot? If you look at this, it's a derivative, right? It's a differential equation. It's not the original. We want to get to y. That is about as pretty as a separable as you can get. When one's in the bottom, one's in the top, and they match up. So here we go. I'm going to try to write the steps. This is already, no, I can't write this. Already set up for cross multiplication. So step one, this would kill me being my step person. Cross multiply. And just think about going dy times y squared. So you get x squared, doesn't matter which way side you put them on, dx, equals y squared dy. Do not try to integrate if you don't have your x's with your dx's and your y's with your dy's. Ming, guess what step 2 is? Look at you, cheater. You totally cheated.
Oh.
So now you can, remember, it's like one of that thing back when you learned in Algebra 1 when you were solving equations. Whatever you do to one side, as long as you do it to the other. So you got to integrate both sides. And like I said, this one's absolutely perfect because when you integrate that, you get 1/3 x squared. Try that again, x cubed. I'm going to put the plus c on this side just because I usually put the y on the left. I totally did this backwards. If you look at my notes, I did it the other way. I want it to match up. Now I'm going to show you what's going on here.
How do you know which side to put this?
Doesn't matter in the least.
Yeah.
Okay. So technically, and this is why I typed out my notes, guys. So if you not typed, but wrote out my notes so you could read this here, because this is going to be hard for me to write. Technically, you got a plus c on both sides, because when you integrate, you get a Hodifi. But what every human on the planet does is if you have a c on this side, you have a c on this side, they move it over. Now c and c do not cancel off because we don't know what they are. They're arbitrary numbers. So you've moved this c over, so I'm going to erase it out of here now. I think I'm going to erase it out of here. And then you go c plus c, and some kids say, well, what's, c minus c or c? It's c. Or it's k, or it's j. It's something. I don't know. I just call it C still. So even though there was two constants, boom, you move it over, there's really just one on one side. Makes your life easier just to move them both over to one side. Since you haven't found it yet, it's not frozen. It can totally be flexible. Now, as soon as you actually find C, then it's frozen. Question on that? Okay, you have two options here, because eventually your goal is to find C and solve it for Y. And this sucks, because I can't tell you a step. Hey, always solve for Y first, or always find C first. Sometimes it's easier to do one. In this case, you could totally solve for Y pretty quickly. Okay? You want to try? So if you solve for Y, I want to try to do it here. I would probably multiply by 3. Woohoo! And this is going to be honest, usually I find C first because it's usually easier. But I want you guys to see one more idea here. Y cubed equals X cubed plus, why did I put C again? You don't know what it is? You could put 3C, sure, but you haven't found C yet, so as long as you haven't found it, it's C. It's still C. All right? It's just you don't know what it is. I'm going to take the cube root. Now, Y is equal to the cube root of X cubed plus C. So when they give these are usually 5-point problems on the AP test. You do this, they usually give you a point just for you understanding. You separate your variables. They give you another point for actually integrating. They usually give you another point if you can solve for Y, and another point if you can find the C. So, again, you've got to persevere. There's a great chance you get one of these you can't finish all the way. Like solving for Y can get really hard with natural logs. But you can do everything else. Yeah.
So you can, so when you multiply C by 3, it just stays C. But how come when you do the cube root?
Well, if the cube root went to both little pieces, I could say it was C. But do you see how it's underneath that cube root connected to the X?
Right.
So then I'm not going to change it to just, like just C sitting there. Because the kid's still under a cube root sign.
All right.
Now, I'm not sure I truly would have solved for Y first, but I decided to do it this time so that you guys could see me play with that C value and realize it doesn't really matter. But at some point, you got to find C. The only way to make it a specific solution is to have an initial point, which they give us. They tell you the point 0, 2, which means X is 0, Y is 2. So you're going to plug it in. So Y is 2, X is 0. Holy moly. Looks like 2 is equal to, did I do something weird there? Nah, I see what I did. I'm a ding dong. And you guys should be, no I didn't. I did everything right there.
No, you used the cube root.
Yeah, I thought I put the 0 and 2 in the wrong spot. No, I didn't. I'm still good here. So I'm there. Something's wrong there.
Cube root.
Oh, cube root. Thank you. Now I know what you guys are talking about. Yep. We better find C. Let's cube both sides. C is 8. Now, if this wasn't a Thursday night where there's almost nothing I'd rather be almost nothing. Wait, let's try that again. Let me finish that. You can tell I can't multitask very well. There's pretty much nothing on the planet I'd rather not be doing than this right now. But if we had more time, I would totally take this and show you could find the same C value up here. If you went times 3C and did all that things and still solved it, you'd still get the same value. Okay? Questions on that? Now, you aren't going to get one that easy. So the reason that was easy is when you separated them, you cross-multiplied, everything lined up. Oh, look, x squared, no, x and dx and y. You're not going to get that. But that's the idea. Cross-multiply, separate, integrate. Somehow, again, I usually find C first. It's usually easier to plug in and find C first, then solve for Y. Solve for Y is usually the hardest part, as weird as it sounds. You know what I think you guys should do? There's a baby. Baby. You and your elbow partners, bust that out. Now, listen, you can't truly finish this. Can you guys see why you can't finish it? I didn't give you an initial condition. So this should literally take you 3 minutes.
Oh yeah, my letters are different than yours. Mine's y over x.
Yours is y over x.
Yeah,
Let's see.
Yours is x over y.
So mine's too easy.
I like this better.
No, mine's too easy. I'm going to cross that out. Do y over x. It'd be better for you. It's like the green NyQuil. Doesn't taste good, but it's good for you. Actually, it's probably not even good for you. You aren't old enough. So I'm going to do yours too. It's hot in here.
Sorry.
You're dark. How's Big Carl?
Oh, man, he was good.
Ming, you know what I just thought about?
What?
I'm going to be looking at you again in like 12 hours.
I know.
Is that insane?
Isn't that great? Don't you love seeing us?
I guess, but I kind of like to see. I haven't seen my fiance since 6:30 this morning. Kind of like to do that.
Calculus tomorrow.
Right?
You got to see me twice today.
Oh, yes.
Just bring your wife.
Just go extra long tonight and not come tomorrow so we can all sleep in.
Yeah, I heard you.
It'll be worth it.
I like you guys, but you're crazy. Now, I'm going to slowly show you steps. I'm hoping that when you guys move things around, you're probably every bit as fast as me since I suck with this pen. But, like, did y'all get the 1 over y dy equals 1 over x dx?
See.
And I'm going to freeze it. I'm going to keep integrating. Actually, I'm not going to freeze it. You guys got an answer key already. I filled everything out. And if you aren't prepared for 1 over y and integrating, you're in trouble. That seems to be what they fell in love with these. Everyone I've seen, I think, in the last 4 or 5 years has been a 1 over y or a 1 over x. Because the college professors think you're going to screw this up. And I'll be honest, these are some of the hardest to solve for y.
Oh, I know. They're totally different.
That's not what you want to do. You do want to raise things, do you switch forms, all that, yes, but not multiply by e. Technically, you can raise both sides to e. So it totally depends. Is everyone up to where I'm at here? Those are my eyes. I know they look weird. Did everyone get to here?
Yeah.
Dylan, you have 2 choices here, and it kind of depends. Who's your Algebra 2 teacher? Right, so Hodafy's the only Algebra 2 teacher that teaches it this way, but he actually shows people how to raise both sides to e, which you totally can. I do want to show you if you do what your other Algebra 2 teacher did and just switch forms. Watch what happens if you switch forms. This goes from natural log goes e to what's on the other side equals, remember if you switch forms, it's the absolute value of e. Sorry, of y.
Nice.
That's the exact same thing as what Hodafy would have taught you. He would have taught you to raise both sides to e. Here the e and the natural log would have canceled. You'd have absolute value y. Here they wouldn't because you got this other junk connected to it. So you get to the same thing whether you took Hodafy and raised both sides to e or you had someone like me, Marks, or Jensen, and they say switch forms. Questions on that? And this is why sometimes it's hard to solve for y, because this right here. There's nothing you guys can do unless you think back to Algebra 2 skills. Okay? And what you got to do is remember that, and I actually put one of these on my Algebra 2 test just to keep kids thinking about it. Like they'll have, well, let's do this one. Let's start it even easier. X to the second times x to the w. And my kids freak out. I know the rules. If they have the same base, you add them. I'm like, well, add them. Sorry.
Darn eyeballs.
X to the 2 plus W. Now, if you understand what I just did here, you guys good with that? That means that if the rule goes one way, it goes the other way, which means if you have x to the 2 plus w, you can split up to x squared times x to w. Well, now look down here, and they love to do this. Do you see that little plus sign right there?
Ooh.
That means you can break up to e to the natural log absolute value of x. Now remember, plus goes to multiplication on this, e to the c, and I'm about to blow your mind again. E is the number 2.718 to a constant. What does that equal? Still a constant. This time I'm going to call it K. When I start raising them to weird levels, I don't know, it's a natural thing. I switch to K. You totally don't have to switch to K. You could call it C. I went K. E to the natural, wait, what's e to the natural log?
It's 1.
They cancel, leaves absolute value of x.
Heck yeah.
And I don't want to get too crazy with you about absolute values and all that. If there's an absolute value on one side, it's super important, but as soon as they get on both sides, they're both absolute values. That means they're both always positive. So you can actually just say it's y equals kx.
Wait, what? Oh, okay.
He's awesome.
Cx, px, tx, zx, whatever you want to call it.
Do you have to keep the absolute value stuff in there the whole time though?
You do until you have an absolute value on both sides.
Okay.
Yep. In fact, one year they made one that was not true without absolute value. In fact, it was really tough to solve it. So what we're going to do, really, we're going to do about 2 or 3 more, and I'm already going to call it. Because the problem is I can't throw all of this at you in one night and have you absorb it. So we're going to do this idea right here, and we'll do 2, 3 more, 15, 20 minutes, I hope. And then I want you to go home and try one. I already gave you one. You already have one in the packet. Then you'll see what an actual AP level 1 is. We'll talk about it tomorrow. So what I want you to do, I'm going to hit enter. I want you to try that one. We're getting real. We're getting real. What you got, man?
So on the test, really, every time we get one where it's like absolute value of y, does it always like even out with another
No.
absolute value of x?
Most of them. So if that doesn't happen, you just carry those absolute values all the way down. Because every time I've seen that where it doesn't cancel off, you only can miss out on 1 point as long as you carry those all the way down. Because some kids can't completely solve because then it might have a domain restriction.
You don't like make it into like a piecewise function.
No, but sometimes it's like, if it's the absolute value y is equal to whatever it is over here, is only true when x is greater than something. And so one year the last point you could give is if you understood the domain. To be honest, I'm not real worried about it. If you get 8 out of 9 on that particular problem, we're kicking butt. All right, I'm going to freeze it. I'm going to try it. Now, this is the actual wording of the AP test. Find the solution of... Nope, I lied. That's close. They usually say find the particular solution and all that. Can I freeze it and do it and you do it? I do it, you do it, just like that. I hit something weird.
Oh, okay. That makes sense.
I can't believe Saputo likes to teach like this. Now I just need a beard and a man bun. Yeah, right. It was so hot I couldn't.
Okay. Okay, I get it. Darn that C. Okay. So y equal.
This is a pretty classic one that you get like 1 point for understanding you cross multiply, but since things don't line up, you get another point just for trying to get your variables the same. Which I'm not even going to freeze it anymore. And then this is, uh-oh.
I'm saying 1 squared plus y squared. It's a good equation. When it's on the bottom. Right iteration.
C, right? 1 plus C. Tan versus 0. is just-
Austin, this is something they would love to do. Because you can do all this great work, split it up, you can be like, I know what's going on, you can't fool me. And then all of a sudden they say, really? Can I not? Austin, can I fool you when you have to integrate 1 over y squared plus 1? Because I know first thing that should go to your mind is u substitution. And if u is y squared plus 1, you need a 2. Not doing that. What are we doing then, Austin? I wish I could do that. But to do natural log, I'd have to call this the u, and I'd need a 2u or 2y, and I don't have it. I remember back in the day when I taught you something, I taught it to you with an x. I taught you the derivative of tan inverse is 1 over, and I think the way we learned it was 1 plus x squared, like that. So that means if you integrate 1 over 1 plus x squared, you get tan inverse. So if I integrate 1 over y squared plus 1, you get tan inverse of y. And I hate to do this, but this is...
So we're not doing this?
No, that is, but I need more room.
Okay, okay.
I didn't know how else to do it.
That's the way to the thing.
What if you go on the other side?
I think if this was an AP problem, and I think if they were grading it, it's 1, 1, 1. 3 of the 5 points came to me with not a whole lot of horrible work. Could anyone actually solve this for y, though? Because if you solve for y, you get another point. What would cancel a tan inverse?
Tangent.
Right, I'm teaching that tomorrow in Algebra 2 if you guys want to stop by.
What period?
Last period of the day.
Sure.
So then I have y equals tan of x plus c. You just got another point. You know why? Because you just solved it for y. What do we have to do to get the last point? Find c. Now remember, be careful. This point is 1 for x, 0 for y. So I put in 0 equals tan of 1 plus c. Oh boy. How do I solve that for c? You totally can. I'm going to try something different just to show you guys something, okay? You've earned all the points you're going to get, good job, for solving this for y right here. You have 1 point less. I might try to find c back here, just to show you that you can find c in many different spots. Right there might be an easier place to find c. Because if I plug in 1, it actually turns out to be the exact same thing, but tan inverse of 0, to be honest, you could be, the AP lets you get away with a lot of stuff, kind of slimy. You know what you could call C? Let's say, does anyone here, how many of you know, because this will be a non-calculated problem, how many of you know tan inverse of 0 right now? Anyone know tan inverse of 0? So if you know it, awesome. So tan inverse is when you look for an angle that has a tan value of 0. I could see you guys shooting it up. There's 2 spots where it happens at. Okay, I don't know if you know it or not. If not, watch this cool trick if you totally forgot. AP does not grade you on simplifying things. You could also just say C is equal to tan inverse of 0 minus 1. You do that, even not putting it in there, I just got all 9 points, or 5 points, because that's all they grade on this part. 5 points. Whoops. So I found the C, I solved for Y, I just got 5 out of 5 on it.
Do you think it's probably better to do that so you don't make any mistakes?
For sure, you never simplify anything unless you're confident you're not screwing up. As soon as you simplify, you're guaranteed you're going to lose a point or two. They don't grade you on simplifying. Yeah. So the question for you is when you're thinking about tan, and you're thinking here and here, there's 2 spots that are in question. It's either good, and depending, let's just do it this way.
0 and pi.
Hey, I'm not saying you're wrong yet. But back if you had me for Algebra 2, we used to have something called a unit circle, and I'd make you write out these points and these points, and if you want tangent, what's the definition of tangent? Don't tell me opposite over adjacent. What's the other one? Sine over cosine. So you gotta remember what your sine is. Y. Cosine. So sine over cosine of pi over 2. Guess what tangent is there? Right.
I thought it was cosine over sine.
Yeah, and so that's the reason it's such an easy thing to get backwards or cross-eyed or whatever. So I always say, if you can leave like that, leave like that. If you can get like that, leave like that. All right. I say we do. What do we got? One more?
Heck yeah.
I don't know. What time is it?
Taco time.
Jeez.
Like 7.
I can't leave too early because my fiance is going grocery shopping tonight, and if I leave too early, I have to go with her.
That's that bad.
Just go look for a car at like Winco's and
What?
Wait, so that's the answer, or did you have to write it down as
So
plug C in and write it all out?
you could. So the way they grade is, and so I only went up to one grading session, but here's when I saw how they graded this. They did a point for separating your variables. So you got 1 point for this. You got 1 point for getting your y's with your y's and then your x's with your x's. That's 2 points. You got 1 point for being able to solve it for y. And you got another point for finding c. They never said you had to actually like put it all in at one fell swoop. But those are all the things they're going to grade you on. If you want to, you could if you really wanted to, you could totally do this too. You could do y equals tan parenthesis of x, and you could just write c that way. It's plus, and this is hard for me, parenthesis tan inverse of 0 minus 1. That's also 100% correct. Now, if you know where tan inverse of 0 is, but the one person who spoke up gave me the wrong one, so I was like, hey, instead of putting the wrong one in, just leave it the way it is. All right, let's do at least another one. Should do 2 more. Actually, what we'll do is we'll do that problem that I brought in from 2000 whatever BC. Yeah, Mrs. March was just being born. I would like to maybe call it at 7:30 and call it good, like a regular class period. You okay with that, Patricia? The idea is if we get out here way earlier than we were thinking, maybe you could actually do, Connor, one of those problems that I put in your 2013 AP test, actually give it a shot. Well, this one looks a little burlier, doesn't it? Ooh, I like it.
It's pretty fun.
Wait, so do you have to isolate y when doing this problem?
You have to get all the y's with the dy's. You gotta get all the x's with the dx's.
Well, yeah, but do you have to find, like, to get all the points in the problem, do you have to find an equation where y is isolated, or do you just have to find the
So
constant?
you have to find the equation with all the y's on the left-hand side.
Oh, well, okay, yeah. Well,
What's that? Okay. I haven't even started yet, so I'm not being very good here.
no, I was just asking if this was okay.
let's see. No, I went just as far as you did. So sweet. I mean, I'm good.
So I got to this. Would that be okay? And then flip that.
Yeah, and then you'll split this into 2 arrows.
Wait a minute. Oh. I'm dumb.
You have to get y isolated, or all the y's isolated by themselves on the left. That's what you got to get to. You don't have to get, like you have y squareds and things, you just got, remember, you have equations with y squareds. Y squared equals 9 minus x squared. That's an equation. That's totally fine. So you just got to get your y squareds and y's on the left.
Right? Y plus y squared.
Yeah. I doubt you have y plus y squared.
Well,
Yeah,
like,
you have the right idea.
I might be getting better at this. I'm just saying maybe. Maybe. I said maybe. The pin had moved on me.
It's like a street light that's crooked a little bit. It's like in the cartoon when like the guy comes flying and his head hits it, and then at least his head is into the street light.
That reminds me of this thing on this one street. Instead of moving this log, the street guys who were supposed to paint the white line just painted the white line around the log.
Oh yeah.
And the caption says, "The ultimate, not my job moment."
Right? I've actually seen stuff like that before.
You're like, how long has that log been there?
Chris, you're beautiful.
Oh, thank you.
Yeah, man.
Thank you. You're beautiful too.
You know, you don't have to thank me for just, I'm just speaking the thoughts.
Can I throw up when you do it?
Sure. It's okay. It's good to be honest.
It's good to puke.
It's a good bodily function to get rid of.
Cleans the system out.
Yeah, a little bit.
It's just too
Is
small
that
for my
one isolating
legs.
one?
Yeah. Yeah.
Oh my god, this is awful.
I thought we actually had to get rid of everything else.
Chris, I like your enthusiasm. I see why he does. This is a pretty lazy way to teach, man. You just kind of sit your leg up, you kind of write on this little thing. It's hot in here.
I'm stuck.
No, and he always calls it a can of soup.
I'm stuck.
Yeah, he's kind of weird that
Then
way.
he microwaves in the microwave, in the can, and then he expects
Consult
to eat more.
JJ. JJ's fine.
Yo. What do you need?
Pass this, JJ.
That's all you need.
Just ask you basically. So don't judge me. You don't have to solve for y anymore because you can't. Right?
When there's two Y's, you can't. No, yeah.
Okay.
Oh, so I don't have to get rid of the one half.
You just find it.
I thought I had to get rid of the one half. That's easier than I thought, JJ.
Same.
Now, I went as far as I could and I ran out of space. There's one last thing I should do. You're freaking me out, Haley. I don't know what you're taking pictures of, but that's makes me feel weird too. I actually should go one step farther. I found the C, I did it. Really, I should probably just put the 1/2 in there. But I ran out of room. I don't. Actually, you know what? I got an eraser on this thing. If I figure out. Oh man.
LN1 is 0.
Yeah. The log of any one is 0. I can't get back in there. Boom. How many you got that one? I think the part where it says, hey, y of 0 equals 1 would be a good shot.
Wait, so you don't have to get rid of the LN, the 1/2, and the Y?
Good luck doing that, man. That's tough.
Yeah, I was stuck here for like 5 minutes trying to do that.
And Chris brings up a good point. I would say it's a coin flip if you guys are going to be able to solve for y. It's a coin flip. You could get to one where you're not going to be able to. This one's good enough right there. They get full credit. But let's say you get to one where you can't solve for y. Man, don't sweat it. But you plug in that and find your C value. Because if all you lose is 1 point on this problem, we are really lucky since we learned it in one day. I took an entire class on college to do this junk. Which was one of my favorites, actually. I'm thinking one more, and then I'm going to work on this thing right here. This should only take us now about 5 minutes. Actually, let's take a break and do this one now. Let's take the blank. Take this blank bad boy. Ah, cheater, cheater.
Pumpkin eater.
So, you know what? Maybe we do this whole thing. Maybe this is it for us today. We'll just go to this. So, I think I'm gonna shut that bad boy down. And what your goal is I did this. I don't really remember it. There, that's now it's a BC, but now because the way they're mixing it up, they're gonna basically make this an AB question. Try it. All I did was rip it out of the test and take it. Nice.
It's not gonna say when you're worked on that.
How do I stop the recording? Oh yeah, F10. Look at you.